In this video, we're going to talk about conformations of alkanes. Now, conformations are different spatial arrangements of a molecule that are generated by rotation about a single bond. Another thing we need to understand about conformation is that it happens without bond breaking. Now, in this video, we're going to focus on an example using ethane to show it. Now, using ethane as an example, when we consider the principle of free rotation about carbon-carbon bond, that's the single bond. Remember, conformation only happens on single bond. Now, we can have many conformations that are possible. Two conformations, however, are very, very popular. We have the eclipse conformation and we have the staggered conformation. We can use the Newman projection to show the carbon-carbon bond. Now, for staggered conformation, it goes like this. This is the staggered conformation. Now, we have the eclipse on the other hand. Now, one thing we need to notice is that this actually covers this. This actually covers this, but we just need to keep it closer just to show that there is actually another hydrogen atom behind them. Behind this hydrogen, there's another person. Behind this person, there's another person. So this is eclipse. This is staggered. This is staggered. So this is staggered conformation of ethane. Eclipsed conformation of ethane. So here in staggered, the hydrogen atoms are placed as far as possible from each other. Here they are as close as possible. Now the staggered is more stable than the eclipse. Since it is more stable, it has least energy. Since this is less stable, it has higher energy than staggered. So if we consider staggered, if we use butane as an example, staggered conformations are further subdivided into two, which is the anti and the gauge. The gauge. While eclipse is also divided into fully eclipse and eclipse. So if we are to draw the anti using butane, this is the anti. This is the anti. Now we can have gauge. The reason this is the same thing as this, but just to show where the bond is attached, carbon is to carbon. So that's why we replace to bring the hydrogen towards this side, but it's also the same thing, methyl. So this is gauge. We can also draw it this way. So any one of them, two of them is gauge. For eclipse, we have fully eclipse. So let's use this for fully eclipse. It means the two methane will actually be the same place while the hydrogen, so fully eclipse. But why the eclipse is we have the methane separate, the methyl, sorry, not methane, methyl. We have the methyl separate. So this is eclipse, while this is fully eclipse. Another thing we need to consider, also note, is that the anti, that is staggered conformation, is slightly lower in energy, and because of that it is more stable than the gauge conformation. On the other hand, fully eclipse conformation is the highest in energy, and because of that it is least stable. And finally, on that, we need to note that the conformation of a particular compound is not actually different from the compound. It is the same form of compound. It's just that it is a different form. It is a different form, but it is the same compound, but it is in a different form. Now we look at conformation of cycloalkanes. In organic chemistry, 6-membered rings are more common than other rings, or even any size. And because of that, we'll be using cyclohexane to explain the conformational features of cycloalkanes. So hexane will be used. Now this is the normal planar of cyclohexane. This is a normal planar conformation of cyclohexane. But we need to know that cyclohexane does not assume the planar conformation of a regular hexagon. This is because it will mean that the carbon angles will be 120 degrees. That's this. Now, but there is a significant stretch. It has to stretch itself. That's because of that we have two types of conformation that we can achieve from that are non-planar. The first one is the chair conformation. The second one is the boat conformation. Now for the chair conformation, it looks this way. A sketch. So this is the sketch, and we have like this. Now, we can understand when we look at this closer, we'll notice that there are 12 hydrogen atoms, and they are divided into two groups. 6 of the hydrogen atoms are orthogonal to the plane, and because of that, we call them the axial. We call them the axial hydrogen atoms, while the other 6 are located approximately to the plane, and because of that we call them like these ones. Now we call them the equatorial hydrogen atoms. The other one happens to be the boat. So the boot conformation. Now the chair is more stable than the boot conformation. Please, if you haven't subscribed to my channel, please click the subscribe button and also click like and leave your comment in the section. Thank you.